Hello, I'm Robert and welcome to my channel where I talk about everything automated algorithmic trading or simply algo trading. Today I'm going to continue with talking about the Learning Python series, and we're going to take the next step. We're going to start with the most basic trading indicator that is the premise of all trading, the moving averages. And we're going to start with explicitly the simple moving average. There are at least 30 different moving averages available, and over time we are going to tear all of them apart and see how they work. But to start, we need to start with the very simplest one, which is the SMA. So what we're going to see is how this chart really is just a series of numbers, and those numbers are what the computer really sees. We're going to see just how to actually make this moving average appropriate to what we learned in the last video from the OHLCV data. Of course, that's open, high, low, close volume. But to do that, we need to get into some of the basic principles of what we covered in the Learning Python series to begin with. So let's get straight into the VPS and actually start working with it. Okay, here we are in the VPS, and I want to start this discussion by going into the Python interactive environment so we can do some more talking about lists. Everything that deals with the OHLCV data is a list, including the data itself. So let's start with a simple list, and we're going to put 10 numbers in it. So there's our list. Now we're going to define the length of the list. Now, the thing to understand about lists, the first element in the list is not 1. So if we actually try that, we get the second element. The first element in a list is 0. So all lists in Python are 0 based. This is important when you want to get the last item especially. For example, if we try to do L as a variable, well, actually, that's what it should be. We're still going to get the same error. Index out of range. That's because we don't have an element number 10. But we do have an element -1, or 10 minus 1. So you have to take 1 off your count to get your actual element or index number. So now that we have the list, we have the beginning point, and we have the ending point. Now we can begin to figure out what makes a moving average actually move. Well, that's easy. It's called a window. And in Python, that's the first value, a colon, and then the ending value. In this case, our window is going to be 3 numbers wide. And that gives us exactly 3 numbers. So now we can find out what the sum is, and then divide by 3 to get the average. So we have the average of our first window. So now we look at the second window. And we have the second average. We do this over the entire list, and that is what makes the moving average move. That's what actually puts the whole process together. But the limitation to this is we have to have exactly that size of a window. So if we have a 20 period or 20 candle moving average, as what we saw on a chart, then we have to have 20 numbers. In trading, you cannot just take an average without a complete list, because the numbers won't reflect the market condition properly. And we are going to see that as we begin looking at the code in a few minutes. So now that we have the basis of it, there's one other thing that we need to actually talk about, and that is when we get the OHLCV data. The last candle is always the live candle. So we need a way of being able to take out that information. And that is simply a colon and then L-1. So now we have the list without the last number. That is, we don't have the live data. All we have is historic data. That is critical when you want to do an analysis. You don't want your numbers changing in the middle of the analysis. And that's what the last candle does all the time, as I demonstrated in the last video. So now let's go through and look at this process. First, let's actually see what the output of such a program looks like. Okay, now I am going to run the program. We're going to use Oanda, cherry blossom account, Euro USD, and the 1 minute time frame. Now, I'm going to use a command from Linux that's going to pause it on the screen, and this just tells me how much my scrolling is going to be when I need to. We'll see that shortly as well. If not in this video, then definitely in the next. So now we have the process running. Now yesterday this was a bunch of weird numbers that showed milliseconds as a single number. Today we've taken that down and actually displayed real time and date that we can read. Then we have the opening, high, low, close, volume. OHLCV. And notice this column doesn't start till all the way down here. This is the moving average. We don't have 20 numbers, so it can't calculate it. So here is the moving average of Euro USD for a 20 period. Let's go to the end of the list. And what you see here is exactly what we saw on the screen with that pretty little picture. It's a big difference when you're looking at the numbers versus the pictures. Both say the same thing, but as you look at them, it doesn't look that way to your brain. Our brains are wired to see pictures, but the computers are wired to see numbers. Algorithmic trading is about numbers. The pictures are just a way that we can see it, but it's meaningless to the machine. This is what the machine really sees. So let's get into the program now. So we start out the way we did yesterday with the basic introduction and the needed modules for getting things running. Now I've added a lot more comments in order to help you get the idea of what's going on in the program. So let's start out with calculating the simple moving average. So what this does is once we get the OHLCV records from the exchange, we want the length or the window that we want to interpret, and then the index of that list. In our case, right now, the closing value. So we have here the list. Open, high, low, close. So we're going to use the fourth value of this list. Remember, time and date is 0. So the index is going to be 4, and the length is going to be 20. And that's what we've done. We use the range function to count numbers. In Python, range generates a number. In this case, we know the number is going to be however many is in the list we pulled, which will be 5,000. 4,999 once you take off the live candle. So we're going to count every single candle in this list. And we're going to go from the very first one of 0 all the way down to the last one. So now what we're doing is we're checking if the current index of the list, as defined by I, is less than length minus 1. Length is the window. So if the window is 10, then its index reference, length minus 1, will be 9. So if the count of I is less than 9, we don't have a full list. So we want to actually add to the new list the original data, that is the original OHLCV data, which we see here, all of these first bits of information. This is the original list. So what we're doing is we're creating a new list, and then that new list is going to be the original list plus the new column. In this case, the new column is a none reference because we don't have a complete list. Once we do get to the point that we have a complete list, a complete reference based upon length, in our case, in our example, 20 periods. So once we have 20 periods, we set the counter to 0. And now we start counting the row we're on the data. And we actually take a look at the counter. And like we did in the Python interactive system, we have the starting reference, which is the original counter, minus the length of the window we want, and then we add 1 to it. And here we simply want I plus 1 for the end. And it will add it up. So let's see what that looks like. Let's actually modify this a little bit. Print out the results and see what this does. So let's take CLOSE sum, and then let's print this actual list. Let's actually see what the program is actually looking at. We'll save it. We'll come back over here, Q to get out of it, and then we'll reload it, and now we'll fix our bug. Okay. Always check your case. Okay, now that the world has finished conspiring against me with my connection, always check your case. And yes, sometimes it happens. So let's now see how this looks. What is the program actually showing? And now we can simply see the first number is the closed sum, then the list of what the program is looking at. Let's actually press the right arrow once, and this is where the less command helps make it easier. We can see how these numbers change, and they move one by one. That is, the window rolls. And that's the critical point of this whole process. We see the window rolling. We see it doing what it's supposed to do. So that as it continues to build the numbers, we get to the point that we see the finale. So let's clean this up. And get our list back to a readable form. And we see our moving average as it goes through and calculates each number one by one. So that's what we're literally doing. And then finally, we calculate the average of the sum we did. That is the sum of our window. It's just sum divided by length is average, and then we add that average to our existing row. And that gets built in terms of a new list. So as we continue, our new list grows one by one as we build our moving average that looks at the last 20 positions of the window. And then of course, we actually look at the list itself. This part here is pretty much what we talked about yesterday, but I've added a few more checks and balances. And that is, now I'm explicitly looking for at least 4 items. If I don't get the 4 items on the command line, then I display the help. Otherwise, I do get what I need. Then I look at the last one. We need 5 items total, but here I've tried to make it so that the program can help you know what time frame you want. So let's actually see that. If you take the time frame off, that is, you have 4 items on the command line. And remember, the command itself actually does count. This is item number 0. So, as you can see, without the time frame, it will tell you what time frames this particular broker or exchange supports. And we're going to use the 1 minute time frame, M1. So by building on what we set yesterday, we can now help the user figure out what is needed. So as we've done that, we now get the time frame. We pull 5,000 candles and we shave off the live candle. Now we build a new list, OHLCV1. We calculate the SMA from the original list with a 20-period moving average, and the index in the list is 4, or the closing number. Now we simply walk through that list and display it on the screen. We take by getting the very first number, the time, dividing it by 1,000 because that number is in milliseconds. And now we go through the process of converting that number into a string we can recognize. And that is done through the date time module. And it converts it into a string for year, month, day, hour, minute, second. You'll get used to seeing this notation quite frequently because we use it a lot. Now here comes the interesting part. We do a little bit of cheating. Python has what's called F strings. They make it easy to format numbers. So let's take a look at that in the Python Interactive Editor. Well, it'd help if I put the right command. Okay, we have the interactive editor. Now, let's define a number of 1.13456. Some really weird number. Okay, there we go. So we have our number. Now, of course, we have to close the quotes. Now, what this does is it formats a string, the variable, the colon, and then the precision. And in this case, an F is a floating point number. So it counts the number out to 5 digits. Now, what if we want to only use 2 digits? Well, it does that too. But it does it in such a way that we can use it in a print statement. See, normally you can't print the number directly to a string. That is, you can't say that. But you can say this. So this is how we can convert to something we can see on a string on the screen easily. It's called a string variable. And that is exactly how the program prints all the numbers in column form, because we tell it the precision that we want. Now, remember when I said that each row is actually a mini list? Well, that's what this takes advantage of. As we begin to actually look at each item one by one, we break it down into a mini list. Let's see how that looks. Let's actually look at an individual slice. Okay, we're going to want to pause the screen because this is going to get messy. So as you can see, it goes through the list and then it prints it one by one. Now the reason it prints the slice so many times is the for loop is going over each item. So 1, 0, 0, 1, 2, 3, 4, 5, 6 items in this list, so it printed it out 6 times. But we see that the calculation for SMA came back for none because at this point we don't have a list. So let's get rid of this line. And let's run the program again. So we see how it's able to build each of these numbers based upon the format we've chosen. And we've introduced something else. If slice is not none, as we saw, if there's no number, then that column has the word none in it. So here, if it's not a number, meaning it's equal to none, we don't want to print it. We can't print it. So items that are none don't get a number, which is what we see right here. None of these items have a number. They're blank. Now, if we had another column here, then we would need to figure out a way of spacing it out. But for now, we don't, so we'll keep it easier. Okay, and now that we've built this string, because of what we're doing, we're using an F string, like what I just demonstrated. We're formatting the numbers in such a way that here we can print the entire string, or each line as we see here, in a nice, pretty way that we can see in columns, and not just raggedly all over the place. Like we can see here, how this number is nice and formatted, even though it's not 3 digits to the left of a decimal. Or, for example, here. So let's see how this looks with a different kind of exchange. Let's go to a cryptocurrency exchange. So now it's going to load the information from KuCoin, and we're going to see just how important that formatting is. So now we see numbers that are very shallow. Let's move it up a notch. In fact, let's see what time frames are available. KuCoin only supports these time frames. Let's take it to the 1 hour. Let's see what that looks like. And we see, like we did with Oanda, the volume is scattered and all over the place. But it's made in such a nice way that we have a nice, clean, comfortable column. And let's extenuate it one more time, and let's see what it looks like on the daily. Now you can see we go all the way back to 2019 on a daily. And we see the volume is 3 digits, 4 digits, 5 digits, so forth. We even see that the price is out of kilter as well. Without the formatting, these columns would be all over the place, and it would look like a drunken sailor walking. But we have nice, clean, pristine columns that make sense and we can read easily. That's why you want to use the built-in Python formatting to keep things nice and clean. The easier you make your analysis, the better you will find opportunities. And here we go. Today's information. And of course, the bottom thing in a program, run main, the entry point. But this really is the heart of the program. Calibrating the tables, spacing them out, and then displaying them. but the whole driving point is calculating the SMA. And that is simply going through the list one by one. If we don't have the exact number of points or candles, then we add a none. Otherwise, we find out what the average is for that window. In this case of our example, our window is 20 periods. Now let's go and show how this can be extended very easily. So here we have the calculation of the 20 period. Let's go through and build for a 50 period. And we need to give it the previous list. Now we will use the last list that we generated, which is OHLCV2. So now we should have a moving average for 20 periods and a moving average for 50 periods, both of them based off the closing price of the OHLCV data. So let's see what that looks like. Okay, here we go. Basically what we saw before, and this is the 20 period moving average. Now we have the 50 period moving average. But notice nothing up here, because we needed 50 numbers to get that average. And now we can tell from here, looking at the very first number, now we can start looking at things like crossovers and cross-unders, because we can actually see between the 20 and the 50 whether or not the 20 is above or below the 50. So now that we have the moving average, and we have a second moving average as well, we have a process by which we can build the next stage of the moving average trading indicator, crossovers. So let's actually go look at a program that does just that. Okay, we're going to go back to Forex, and we're going to go to the second part of this lesson, which goes into the crossover. So everything that we've seen previously, nice pristine candles, the 20 period moving average, the 50 period moving average, and some extra stuff. Now here we're looking at cross under, or whether or not the first number or the first series is under the second. That is the first moving average under or over the second? The 20 period or fast line, the 50 period or slow line. Well, right now, the 20 period is under the 50 period. And the false is that the 20 period is not over the 50 period. So now we actually have something we can use, we can test. We can now begin formulating a trading approach. And of course, I show a little indicator here to help me see visually that we have Series 1, the fast line, is under Series 2, the slow line. And we keep going. Now, an interesting thing here, if you subtract these two numbers, you can track the distance. And like what I demonstrated yesterday, Once you see the distance go up and then begin to go back down, where you get that V, you then have your entry point that I showed yesterday on the chart. So now we begin to see just how we can build the introduction trading strategy to capitalize on the bottom or the swing low of a moving average for a long position. Okay, we're still under. There we go, a crossover. So series 1, the fast line has now crossed over the slow line. Now let's talk about that. What is a crossover? Well, a crossover is when the numbers of the current candle, series 1, the fast line, is above the slow line, but the previous candle, the fast line, is below the slow line. That is, the fast line has crossed from under the slow line to being over the slow line. And we can see that numerically. We can see that crossing point here. So now that we have the crossover, we have a whole myriad of options available as well. Now this is just cosmetics so that, again, we can simply track the distance between the crossover, cross under. We can see how wide or narrow the distance is between the fast line and the slow line. And that can help us maximize our entry and our exit points as I demonstrated on yesterday's chart. Okay, so we have the crossover, and now we have a cross under. So the fast line went up and over, and now it's going back under the slow line. So this is now how we have a trading approach. So let's actually look at the code to this. And the code to this one is actually very interesting. So again, we see all the basic preambles. Now we get into the actual crossing. That's the actual function, but how do we actually take care of that? Well, it's very simple. Right here, we've calculated the two moving averages, and now we calculate the crossing. Now, we know for a fact that the first moving average puts its result in column 6. The second moving average puts its result in column 7. So now, using that information, we calculate the crossovers between columns 6 and 7, where 6 is the fast series, 7 is the slow series. So let's see how well this works. Okay, we start our new list, we start our checks, and we walk through the entire series of candles. Now we start out with the convenience. Current row is just equal to this OHLCV data point. If I is 0, this is a special case situation where we don't do anything at all because we can't really look at the previous line. A crossover requires the current row and the previous row, the current candle and the previous candle. We don't have a previous candle on index 0, so there is no crossover possible. So now that we have a previous candle, we assign it to previous row. So now series 1 is current row of column 1. Column 1 in this case is the fast line. Series 2 is the current row of the slow line. Simple and easy. If at any point series 1 or series 2 doesn't have any data, then we simply skip it. That is what we see up here. No data until we reach where we have 50 for series 2 or the slow line. So now that we've done that, we've eliminated a lot of headaches. We can't test what we don't have. So now we simply check to see if is series 1, the fast line, under series 2, the slow line. So if the fast line is under the slow line, then this will be true. If the fast line is over the slow line, then this line will be true. And now we simply save the results. And that is what this T and F is. Under, over. Now we did a little bit of screen magic, which I'll get into in a few minutes, but we begin to see how we've actually isolated the whole approach of checking under and over within the program. So now that we know under and over, we can actually tell a crossover. And that is the whole point. Okay, now we add the line to the new list and we return the line. Okay, now we check the crossing. The actual crossing. Is right here. Here's how we check it. But this looks confusing and complicated. It's really not. And here's what we're going to do. Let's start with what we already know. The basic display format for all the numbers. Here it is. Now we've added something slightly different. Because of our columns for the T and the F. That's not a number. Python calls that a Boolean. So let's see what that means. So now, 1 equals 1 is true. 5 greater than 4 is true. But now what if you try to print you're going to get the word true, but that's not a string. That is, you can't print a Boolean and a string. It doesn't allow it. And in fact, we can actually test this here. Class bool, Boolean. True, false, yes, no. So what we can do is we can tell it to convert that to a string. And hello, well, it helps if I type right. Hello, true. Now, I only wanted one letter. And now we have index 0, the first letter of the word true. str converted the Boolean to a string. That is what we're testing here. And that is actually what this is doing. If the column is a Boolean, then take only the first letter of the word after we make it a string. Otherwise, do what we did previously and simply make it a pretty number. And now here we actually test under and over. So let's go back to the program. Okay. If this number is less than or under this number, then we put a less than symbol. Otherwise, if this number is more than or greater than this number, then we put this symbol. It's strictly a visual reference. And remember, this is zero based. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we put that in a column form. But as you can see from here, 8 and 9 are the true and the false, the Booleans. And that is what we use here. Now here we try a little bit of trickery. As you see up at the very top of the screen, previous is none. So the very first row in our list will have no previous. And what we do down here is whatever the current position is, the current row or slice of this list, we save that to previous. So that when we move to row 1, the previous row is row 0. And we don't have to do any fancy math to figure it out. That is, we don't have to check the index for 0, because this does it for us. It's kind of a sneaky way of getting around what we did above. So if previous row is not none, then we actually check. Is the slow line true and the fast line false of the current row? If so, then is the slow line false, or excuse me, is the fast line false and slow line true of the previous row? What we are looking at is the top 2 rows of this crossover. That is, are we over and under or under and over? In this case, this is a cross under for the first equation. So let's find cross under. And here is the result of how that looks. False, true for the previous row, true, false for the actual current row. So, false, we are not under the slow line. That's the false. And the true is the slow line is over the fast line. Another way of looking at it is greater. We see that 109,774 is greater than 109,773. So the fast line is more than the slow line. And then the fast line becomes less than the slow line. It crosses under the slow line. So as we're building this out, we have a mechanism for a cross-center crossover trading approach. And we could actually do this for any number of moving averages. That is, we can add the 200 period moving average, and we can look for closing price crossing over it, and then look for our entries, which is what we did yesterday. So now that we see how we can actually calculate the crossover, actually look at the crossover and cross under, now we actually have a way of building some point of reference for a trading signal. And we print the information, and then we just move on to the next line. So far we've done nothing but just visualize the market, and we're starting to actually show how to get a signal, how to begin making decisions in the market. So the next step will be to actually try to figure out how to turn this into something that can be traded with or take it to the next level. What can we do with this information? Now, I know this is quite a bit of information I just gave out. So take your time watching the video, use the programs, test them, run them, put print statements in, see how they work. It sounds complicated, but it's really not. This is a step-by-step approach where we simply build on previous information. It's not that complicated. If you have any questions, please ask them. Leave them in the comments. Let me know. I will be happy to answer them. If you thought this video was useful, please give it a thumbs up. Please subscribe if you're not. Thank you for watching, and until next time.